let's get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes in the importance of
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed?
Welcome to another episode of In the Cloud. I am your host, Stu Miniman, and we could say that this episode is going to be out of this world. Yes, we are going to be talking about a special edge computing project on the International Space Station, something that IBM and Red Hat work together on. Obviously, many of us in tech are space enthusiasts, so I, for one, am really excited to be able to talk about it. It's a great example of what IT can do when teams have reliable infrastructure and the software to go along with it. There's actually there's a reason why Red Hat has a new brand campaign. So if you watch television, especially if you watch sports, you might see this new advertisement that we are going to share with you here. Quick 30-second ad, and then we will be back with the program. So please enjoy this advertisement.
Test commencing.
Good code should work anywhere, even in outer space.
Water safety test commencing in 5.
When we know our apps will work in any environment, my team can focus on our code.
We did an extra round of debugging, right?
Yep, the code is clean.
Okay, here we go, everybody.
Houston, water analysis was a success.
This is what connecting your clouds feels like.
Awesome. So, as I mentioned before that, space activity, when I look at cloud computing, what we've been doing at Red Hat with OpenShift, we talk about having our code run anywhere. Edge computing, of course, has been a big effort to be able to make the footprint fit and talk about some of the challenges. Edge computing, we're going to the far edge when we go to something like the International Space Station. So really happy to welcome to the program our guest for today is Naeem Altaf. He is an IBM Distinguished Engineer, and he's also the Chief Technology Officer for Space Tech. Naeem, thank you so much for joining us. And gotta say, I love the space setup that you've got behind next to you there with the rockets and satellites and the like. Thanks so much for joining us.
Thank you so much for having me.
All right, so Naeem, you're a distinguished engineer at IBM. So distinguished engineers and fellows, these are people that have broad experiences and done a lot. Tell us a little bit about your journey to space tech. I mean, you weren't, somebody that started out, you're from more of the software side. So help us understand a little bit your journey as to how you got to today.
Sure. So like you mentioned, we all in the, technology sector, we are space enthusiasts, many of us are. So I think a few years ago, I got the opportunity to work at the SETI Institute as a volunteer. We were working on some interesting projects. And from there, I got this, visibility where, as you know, most of the industry today is going software defined. So, like you said, I don't have a, aerospace background. I'm a computer scientist. So it's like, okay, programming is everywhere, code is everywhere. So it means that we can also be in this sector. So that's how I got interested and started learning about what are the different segments in this space where we as software developers can play in. And that's how all these ideas came into picture, and we'll discuss more about these things.
Yeah, so you're at IBM. Of course, IBM deals with companies not only around the globe, but now you're dealing with solutions in space. So help set the table for us, working with NASA. What was NASA looking to do? How did IBM get involved? What were some of the, the challenges that they pulled you and the team into?
Sure. So when we started looking at, what interesting things we can do in space. So right now, the buzz in the industry, as you know, we went from cloud computing now in the era of edge computing. And the idea was, how can we extend this edge computing into the orbit in space? And the target was International Space Station. International Space Station, as you know, is a laboratory for many experiments happening there. And we can judge, we know the communications we have on terrestrial networks. If you are at some far location, you have latency, bandwidth challenges. If you're in space, those magnify those challenges. So we reached out to Space Station, National Labs, and NASA, and we like, okay, what kind of projects you're running there, which are heavy on compute, heavy on data, so we can do some edge computing for you. And the project which they mentioned was, one of the projects was DNA sequencing. And they mentioned that it creates almost 0.5 terabyte of data on each run. And now that data has to be brought down to the ground through the ground stations. And the way, just a bit of background, when you are in the low Earth orbit, where the space station is around, I think, 250 miles up or kilometers up, you're moving at 17,000 miles per hour. So your touch point with a ground station, any given ground station, is only 7 minutes. And you're talking about radio frequency. So there are several bands, but you're not talking about gigabits of transmission. So in space station, any satellite in the low Earth orbit, if it wants a much more frequent uplink downlinks, it actually goes up to the geostationary satellites. And NASA has a constellation of them for the data relay. So the data goes from the space station up in the geostationary orbit, and from there it comes down to the ground station. And the reason for that is, if you have dish at home, like Dish Network or whatever you have, you probably have noticed, once you put the dish at your home, you don't have to go out and keep on moving the dish, because Earth is rotating satellites. In geostationary orbit, the satellites are in exact motion of how the Earth is revolving. So that's why you have these dishes which can point to your telecommunication satellites. So that's how it works. From the space station goes up and comes down. So while we were working with them, so we said, how about if we perform this computation on the space station? So we worked with the with the NASA, try to understand what needs to be done, and it's a bit complex problem, because when you're talking about DNA sequencing, there are multiple steps involved. You have base scaling, you have the demultiplexing, you have the alignment, and then you have to generate a report. So we took that code, we containerized that code, and we wanted to get the OpenShift platform. We want to put the containers in space. So at that time, 2 years ago, we had the code-ready container from Red Hat OpenShift, which could fit on the single node. So we took that code, we containerized all the code, and we didn't put this. It actually went up last year in April. And since then, we have like 3 or 4 runs. So basically, it's running in production now. And again, the goal was minimize the downlink. You don't want to downlink 0.5 terabyte. Now, for example, when the report is generated, it's literally 1 meg file. So you did all this computation there, and because the principal investigators who are requesting this run, they just want a resulting file. They don't care about all this raw data, and right. So and the genesis of this project was they're looking for microbes inside the space station. So basically, the astronauts, they take a sample from the surface of the space station, and they run through this device, which generates all the data, and we pick it up from there and generate the final report. So these has huge implications for the future. For example, we are hearing a lot about, you're probably watching the Artemis program going back to the moon. The SLS is already on the pad to go up, right? And then you're going to the Mars, and for all these deep space missions. Imagine you have these robots, and you have these DNA sequencer, these devices. So these robots, just like how Mars robot does, right? Rover, it goes and it pokes into the ground to pick up the sample. So what if it picked the sample, and it has a DNA sequencer there, and it can run through the sequencing, and maybe it can find life somewhere. So that's the whole idea about edge computing and edge computing in space.
Yeah, no, it's fascinating when you look at this. It's one of the patterns we look at for artificial intelligence. Often, you might do your training at a centralized location, like often the cloud is where you need to kind of build the models, but you need to be able to deploy where the data source is. So the example we've used in the industry for a long time is, if you look at cars, if I have a car and it has a LiDAR, I can't wait to go back to a public cloud because I will have hit, the thing before I get the data back. Space, absolutely is a phenomenal example of that. As you say, just on the ISS, there's limited bandwidth, but right, if I'm going to the moon, if I'm going to Mars, if I need to be able to analyze data, or maybe look at certain safety concerns where I would be testing things, that would be so important to be able to do that locally. Question for you. You talk about the maturity of Kubernetes. You worked with our team at Red Hat. We spent a lot of time over the last couple of years shrinking the footprint and the amount of resources there. So maybe you could talk to a little bit the intersection of the requirements that they had and the maturation of the technology to reach the successful solution.
Sure. No, so that was it's a great partnership with the Red Hat, and a shout out to the team, at the CRC, and we'll talk about the Microshift as well. So the goal was to reduce the enterprise OpenShift version to a single node 2 years ago, which I know it exists today. So that was the initial goal. Then from there, the next step was, okay, how can we shrink even further? Because when we are talking about edge computing devices, we are talking about devices like Raspberry Pi, stuff like that. Can we have a version of an OpenShift which can fit on this device? And we can, and also beyond, besides these versions of OpenShift, we also have, as you know, Podman to run the containers. So we are using a combination of how it fits, where we use Podman versus the lighter weight of the OpenShift. So that's how we work together, because the target needs we need a lightweight platform, because the footprint of hardware is not as big as you can expect on the terrestrial networks. So that drove all these requirements with the team, and it was a great experience working with the team.
All right. One of the other concerns also is, do I have the skill set to be able to take care of things? So how many Red Hat and IBM people did we send to the ISS to be able to set up, configure and manage this whole environment?
Just one. Yes.
Yeah. Did we actually have an employee from up on the ISS, or was it somebody that was trained?
No. So we have actually we have access to the systems from the ground. So we were able to SSH into the systems. Right. And basically the flight systems were built here in Alabama. So we uploaded everything over there, prepped the system. And once it went up, and it took a couple of months to go live, at that point, we were able to go and start the whole sequence. So, but at this point, minimal, right? Initially with IBM engineer, Red Hat engineer, making sure the system is all prepped before it launches. And after that, it's just a matter of running the script.
Yeah. That's phenomenal. That's you want IT to be able to manage things, out of that. You don't want to have the resource touch there. Automation needs to be involved, remote management, all that sort of stuff. What else? Anything else we should know about, the Kubernetes solution on the space station?
No, so you hit the right point. Fully automated. That's the key thing, because you have at any given time between 3 to 4 astronauts on the space station, and there every minute is scheduled. I have seen those schedules. I was in the ISS headquarters in DC, and I was just surprised to see up to a minute that they will do this, they will sleep for this minute, they will eat now. It's like everything is scheduled for weeks. So we had to make sure that the platform we put in can fully, because like I mentioned, there are multiple steps involved. It's a complicated process. So we need a platform which can take care of, which is resilient, and in case of any failure, it can go back and start. So we shouldn't have to ask somebody, whether on the space station or on the ground station at the NASA, to go and trigger this again. A fully automated process.
That's awesome. You mentioned Microshift. So for
Yes.
those that aren't familiar, Microshift is currently a open source project to be able to take, when we had OpenShift, we can do a single node of OpenShift, so Kubernetes on a single server, but there's still a minimum requirement for how much resources are available. Microshift actually isn't full Kubernetes. There's some things we need to strip out. We need to be able to make it to fit on a smaller footprint. So where's Microshift intersecting with what you're looking at on the space programs?
So that's a good question. So our goal is to introduce a containerized platform for the space industry. And they, as you mentioned, right, there are a lot of restraints here because of the footprint of the compute. So actually, there's a very I think the only conference for the small sat category, which happens every year in Utah, and we just submitted, which got accepted. So this summer we will be actually presenting Microshift to the developer community of the satellite. And it's a huge community. And we want to introduce them that as you are building schools, universities, and the small SAT programs, take a look at this platform, which we will talk about what we are doing in future with this platform and our mission. But that's the idea, right? I mean, make it available to the developers and let them play with it and see how they can, orchestrate, run their different kinds of workloads. Because the think about this, the data centers we have on the ground today, these data centers are planning to move in the orbit. Yeah, it sounds like a little bit, but that is true. They want to move these data centers in the orbit. So you will have basically a cloud will be running in the orbit. So all the things which we care about, the multi-tenancy, right? How can the platforms handle multiple workloads, the SaaS kind of solutions, they all will be going into the space. We just have to be, we can't just go over there physically and do something. So you have to keep that in mind while we are developing these systems and solutions.
Yeah, I had too many years, watching the data center space. The thing that comes to mind is like, well, cooling should be less of an issue in space because we should be able to, vent out heat rather than worrying about other things there. Yeah, but maybe we speak a little bit about the Endurance mission and the Cube satellites and where people can learn more about that.
Sure. So when we started looking into the into the space area, one thing was to how can we also launch our satellite, and this is purely for research and educational purposes. And so we started working on that, and we wanted to use the latest and greatest technology available among us, IBM and Red Hat. And at that time, Microshift was still in it was a thought process, right? So we worked with the team over the year, and finally we have an open source version of Microshift. Actually, this will be launching on June 1st, net 30, which means, because of the weather, it can get delayed few days, but the target is the June 1st to launch this CubeSat, which will be running on Raspberry Pi. And the idea over here is, as I was going through the process of how can we put a satellite, if you look for a checklist, it is huge, and for right reasons, because you have to go through so many steps and approvals. And I mean, if you guys can just Google NASA 101 CubeSat, and you will see this like 200-page book guidelines, which tells you have to follow all these steps. So I was like, okay, if we're living in these modern part of the world, it is so hard. Imagine the developing nations or underdeveloped countries across the globe. It will be almost next to impossible for them to launch something or have access. So the goal was, okay, we will launch this thing and we will make it available to every school kid on the planet. It will be available. So right now we are starting with Ibm Ptek Program, which is the schools they work with all over the globe. And I think the link is shared. So schools can register, and we will give them the APIs, everything. They can write their code in Python, and they will be able to submit the code, and the code will actually go on the CubeSat, execute there, and come back. There are a variety of sensors on this CubeSat from all the positioning. There's like I think 20 different metrics for positioning, vector. You have the all the metrics related for the battery for operational point of view. You have the metrics for the solar panels. You have the heat information. Then you have compute over there where we can use commands like, like nmon. We will have podman there. We will have microshift there. We have AI binaries there, so we can detect, because you have a camera on the CubeSat, so it can go and detect stuff. So we have variety of sensors, variety of metrics, which your code can play with and do some edge computation. And then one last thing, so sorry, once you execute the code and the results come back, we will issue you a certificate which will be created by basically stamped by quantum computer. The number you get will be quantum computer generated.
Yeah, Naeem, I know I was excited when, I could have my name, on something that was like going up in a rocket and like NASA sends you a little certificate. But what you described there, so many home enthusiasts, you grab a Raspberry Pi, it has sensors, I can do that, but you're removing the hardware and it's in space. So how cool is that, that the kids get to play with this, they get there. I would hope that this will, just increase people's interest in STEM. We need, globally to be looking at, the opportunities of space. So that is so awesome to see the activity. Something we expect, a company like IBM to be involved with. So it's great to give back on that. You talk about how everything gets all planned out. I watched lately, it's like, we have the rough date as to when the ISS will, be decommissioned and come down. So what can you tell us about, future activities? Are we planning for future space stations? Are there other, projects that you can share that, IBM and Red Hat are involved in?
Like, cool. Yeah, so space station has been amazing, right? And it's coming to end of life at 2030. And actually, there is a graveyard selected for where it will go in the ocean. It's in the west of Australia, right? That was really cool. I learned recently about that. So now as space station is coming down or end of life, there are new companies who are emerging, because this is what has happened in last couple of years. And a huge, stuff which the industry which has been changed is by SpaceX, what they have done. So basically, the commercial and the private sector is coming together with the government sector, right? They're opening up, and you will see there is a flight going up tomorrow, right? AX-1 for the private astronauts to go on space station. Then there is the Crew 4 going end of this month. So again, going to the space station. But now, since the private sector has come forward, there are many companies, like I think there are 3 or 4 who got the awards to put these space stations, the next generation space station. So if you think about the space station, if you think about inside, it has lots of sensors, it has lots of research equipment inside where they're doing research for microgravity, for growing plants, the food stuff, watching the health of the astronauts, and doing a lot of imagery from on the planet, all that kind of stuff. But inside, to do all those things, you need IT infrastructure, you need compute, storage, and network. And that's what these companies are. We are in discussions with few and talking about, okay, what will be the next generation platform, which is the whole stack, right? Your infrastructure, your PaaS, your SaaS, the whole stack. How will that fit in that space station? And then the rules will be a bit different, how you interact with. Basically, the idea is the space stations will become, because they want to commercialize this stuff, so they will become like labs, right? So you have different kinds of experiments you want to run. So you're on the ground, and a cloud of your choice, and from their cloud you say, I want to access something, I want to run some experiment on that given space station. So that also brings in the picture of this AI sec DevOps. You can add so many acronyms, right? So the whole pipeline, basically. So that is a huge discussion. Okay, how can we build these pipelines where users can build their code? And that's where the cool thing about OpenShift is you write once, you can push your code anywhere. And that's what our messaging is, that we have a platform, whether you are in your data center or you are in somewhere in the cloud, or you are at the edge somewhere on the terrestrial network, or your edge happens to be in space, your underlying platform is the same. So me as a developer, while I'm writing my code, when I push my code, it doesn't matter whether it goes in space, edge on the ground, because the platform underlying is the same. So that's one area. The other area is how do we build these pipelines to push, and then the transmission. There are challenges. The network, disruption between in the orbit. How do we make sure that it's resilient? That whatever I pushed to this far edge, it's the same thing. If it did not got compromised, and especially when we are talking about the machine learning models, it's very, very sensitive, because you're relying on the output of those models. So you want to make sure the model which you developed is the same model which is running over there. So yeah, these are all the different things. I mean, you'll think about the platforms for software development, your data pipelines, how you're going to push. Security is huge area. How are you going to secure the communications? So, and this is basically data center is now going from the terrestrial into the space.
Yeah, and even I think about, public cloud architecture, Naeem, when you talked about, the geosynchronous orbit, do you expect to see a public cloud announcing a region, on the geosynchronous satellites? Because it's probably still going to be a little bit while before they have an availability zone on the moon. So, would the geosynchronous orbit be the first place that, I might have certain cloud services available there?
Most probably in the low Earth orbit. And the reason is now companies are talking about putting a constellation. So you have a ring of, let's say you put 6 or 8 of these mini data centers, and they will be connected through optical connections in a ring. And then based on that, you can route information among each other and push down whoever has the best site to get to the ground station. So I think definitely we will see these edge locations in space in few years.
Wow. It was interesting. I attended back in 2019 when we still had physical events. Amazon held a conference that was, space was a big piece of it. And I geeked out. I went to a whole bunch of sessions and I talked to some friends and I was like, oh, I wish I was in the space industry. And they're like, Stu, compared to the IT industry, the space industry actually moves kind of slow. So I was wondering if you've got a great viewpoint of this. You talk about all the planning, you talk about the 200 pages, today's day, I want to be able to respond fast, spin things up, do instance. So where do you see kind of space and IT intersecting when it comes to the path of innovation?
I think on the development of physical infrastructure, it's going to be slow because you only have one shot. And that's why, I mean, in space industry, one launch failure, you're out of luck. Your company's done. So that part is hard to move faster. But the things which will move is faster is the software defined. And that's what we are trying to focus. Okay, yes, you guys are expert in building these spacecraft satellites. We are expert in on the software side. How can we come together to create these software defined satellites? Again, think about it. The challenge of solving data on the ground. I think this is far more advanced than the type of data you will have in space. I mean, think about all the social media, the amount of traffic flows through networks every day. You don't have that much traffic. So I think we have pretty good idea of how we can build these kind of platforms which are resilient. Now the challenge is how we can fit those in a smaller, tighter space. That's the challenge. And the industry is moving towards COTS. COTS means compute off the shelf. So before it used to be proprietary FPGAs, stuff like that. But now it's opening up because there are companies who are building these enclosures which can protect from radiation. Radiation is the biggest thing to protect your compute from. So they will be like radiation hardened enclosures where your regular compute can sit in and it can do stuff, right? So these are some challenges, but I think that the aspect of software defined for the space industry, that will speed up things.
Yeah. I'm curious. You live down in the Austin area, and we've seen, Texas just seems to be the hotbed for space, these days. Yet in the last 2 years, a lot of the stuff has gone remote. So, speak a little bit, if you could, to what's happening in Texas versus the global participation in all of the space activity. Like your team, is it is it a globally dispersed group, or or is there a core team in one of the IBM locations?
So these days, everybody is in remote locations because of the pandemic or last 2-3 years. So the core team is in Austin, Texas, but we have participants from almost all over the world because we have a thing called in IBM the Academy of Technology, where you go and create initiatives and people worldwide join, try to help you to build those different kinds of solutions. So it's a family, and we also had participants from the Red Hat, of course. So we all working, whoever can contribute from wherever they are in their capacity. So that's where how we are working. Now, if you talk about what's happening in this region, right? So we have Boca Chica, right? It's a cool name. In South Texas over here, where we have Starship, right? And probably guys saw in last year when they did their test with Starship. So I think that is we all are looking forward to that when actually the Starship launch happens, and a lot of things are happening. They're talking about building the next generation of spaceport here in the south, but that will also bring modernization of your command and control data centers, and that's where again our platforms, our technology will come in. So there's a lot of room as software developers with little or no space background. All we want is your enthusiasm and your curiosity about space. I think there's plenty of room.
Well, I guess that's a great setup for my final question is, what are the skill sets that people are looking for those people that work in tech that are enthused, what are people hiring for? What are the areas where, there's real need to be able to, I might not be the person getting on the rocket, but I can help, build the technologies around what's happening there.
Sure. Again, just to look at the recent examples, right? So look at how the booster comes down. That's pure programming. How it's coming down, that's just amazing to watch. Sometimes it looks like we are watching a movie. And then you saw when the Dragon, which took the first crew to the space station, you saw the consoles, right? The Linux-based or Windows-based consoles inside. So yeah, as long as you're hardcore programmers, there is plenty of opportunities. And then if you have again, if you want to be in this aerospace or space industry, you need to understand a bit more about how the dynamics works here in the space. You need to have some ideas about, but if you are a good programmer, I don't see how you can fit here, because they need lots and lots of programmers.
Awesome. Well, Naeem, thank you so much for sharing. We definitely we've got a chat group here at Red Hat that watches all the space flights and really is interested, and great collaboration between IBM and Red Hat to make these solutions work. So thank you so much for joining us.
Thank you so much. It's my pleasure.
All right, so hope you enjoyed this special session about space. Definitely a topic I love to hear plenty about. Just programming note: we will not have the program 2 weeks from now. We will be back in 4 weeks. We've got a lot coming out. If you look at Red Hat Summit is happening there in May, so look for lots of announcements. You can join the event. It is a hybrid event, and registration is open. So thank you so much for joining us for your journey in the clouds. I'm Stu Miniman. We'll see you back in 4 weeks.
Thank you.